Welcome everybody to this webinar hosted by Infineon and Spyrosoft on the topic of safe and effective medical devices built with microcontrollers or MCUs. And today we are presenting here. My name is Tony and I'm leading our software offering called Qt for MCUs, and together with me I have Ankit from Infineon and Jakub from Spyrosoft. So for the agenda, I will first start by talking about key trends in medical for graphical user interfaces and specifically why microcontrollers are increasingly being requested and used. And then I also talk about how to streamline the product creation workflow. Followed by that, Ankit will cover Traveo 2 by Infineon, which is a very, very powerful microcontroller and how it's applicable for the medical use cases. And then I would say that most of the time we will actually spend with Jakub describing a medical reference design called LifeTrack, which is a pulse oximeter that was built with Qt for MCUs and it's running on Traveo T2G by Infineon. And in the end, questions and answers. And the way to ask questions in the tool, you should have a button for questions, so you can write your questions there. So we'll take all the questions in the end, not in the middle. So we'll reserve time for that. So let's get started with the key trends. So of course there are many trends, but we picked maybe the 6 most relevant trends here, and what actually they do apply very significantly also for microcontrollers. The first actually is on high quality graphics. Thanks to the development and advancement of the display technology and panel technology, and also in the microcontroller technology, more and more higher and higher resolution graphics are available, and in many of the use cases, high resolution graphics are actually required for medical to see exactly all the details in the picture. Then the second use case, trend is about intuitive and fast design. So we have seen in the other areas of industry that product development times and the lead time to actually from the designer's desk to actually have a product on the market is running shorter and shorter, and the same use case actually applies also in medical, to be able to run prototypes quickly right on the target hardware. Then a bit interesting trend, how to say, is about reusability of the UI components, and it actually starts to make sense. And when you are looking, many of these applications in the medical are quite complex, and if you have something certified, if you have something that is already passed all the tests and so forth, it is you are able to save a ton of time and when actually reusing those designs and those components that already have been approved. Then on the bottom, safety and reliability. This is actually also the more complex information you will actually have, the more you want to be absolutely sure that what you are intending to show to the customer or the user or the operator of the device is actually what is actually shown really on the screen. So functional safety, that is very much known from the automotive use cases, is also very relevant for the medical. Increasing performance, by that we mean the devices which are quite complex are getting, with the complexity comes maybe a heavy start, but in fact you want these devices to actually start faster, almost immediately. So faster boot times, higher frame rates, and especially real-time processing. And this is especially a sweet domain for microcontrollers. And finally, last but not least, is the quality assurance. and of the device and the software, the whole stack, and oftentimes this is also required to achieve a level of certification. So now, in considering these trends, why are we seeing and why we are witnessing that the Qt for MCUs is good fit for medical, and also the microcontrollers that Ankit will present are very good for fit for medical. The 5 common points, and the more you are addressing these, or the more of these requirements that you have in your use case, the more likely you are to actually select a microcontroller hardware and a software. First is real-time processing, right? The embedded Linux, you oftentimes need to do all kind of gimmicks to actually get the signal processing really on real time. With MCUs, it comes by their nature. Typically, thanks to the simpler architecture, the MCUs and the MCU software is much lower in power consumption. As I said, instant boot time comes as a natural benefit of using MCUs, and often when you have a simpler design, less memory requirements, less layers of PCB, etc., you are then also addressing the reduced BOM cost. It might sound that it's not maybe so relevant in medical devices, but if you are looking the markets, especially in the developing countries where you actually want to introduce this technology, so it does actually play a role that you actually are able to deliver performance and graphics at affordable cost and reliably. And finally, but last but not least, is the lightness or easiness to certify. We all know that millions and millions of lines of code are much harder to certify than a less number of lines of code, and also including the complexity of the target device. So with these, typically when you are looking then at product development flow, and this is what's happening. You have a design, you have development, you have something function called quality assurance, and then you're producing and managing the device. And what happens is that typically at these points when you give the design to developer, the developer gives it to quality team, and then finally to be managed, that there are breakpoints or handover points, and that's actually where typically problems very frequently occur. And at Qt, on our side, our solution is actually to run as much as parallel. The UI development can start based on the prototypes, the logic development, architecture verification, all in parallel, which actually then leads to faster, better, easier development and production of products, and especially in the medical domain. So with this, I would like to hand over to Ankit to talk about Infineon Traveo 2 platform.
Thank you, Tony. Thank you so much for giving us such a nice overview on the key trends in the medical applications, as well as also walking us through on the Qt product creation flow. Hi, my name is Ankit. I am Senior Marketing Manager. I'm based in Campion, Munich, Germany, which is the headquarters of Infineon Technologies. First of all, I would like to say good morning, good afternoon, good evening from wherever you have logged in. On the right-hand side, you see a QR code. This is my business card. You can scan it, and of course, you can get in touch with me in case you have any questions, even after this webinar. Today, I'm going to talk about Infineon microcontroller portfolio, Infineon microcontroller family, and specifically, I'm going to talk about Traveo 2 graphics microcontroller. So talking about Infineon, Infineon is a #1 automotive semiconductor company in the world, and we are one of the important or key players in the semiconductor space. And we are the ones, and coming down to the microcontrollers, we are #2 in terms of market share today for the overall microcontroller space, having a market share of 17.7%. However, we are number one in automotive, having a market share of 28%. So if we are talking about Infineon microcontroller, we have a very comprehensive and scalable microcontroller portfolio. We have MCU families like Oryx, we have Traveo, we have PSOC, we have Motix, we have XMC. But what I'm today going to talk about more is very much centric towards Traveo. So as I mentioned, we have a lot of families. Traveo is a very value-oriented family. These MCUs are optimized for the power. Within Traveo, Traveo T2G is Traveo second generation. We had even the previous generations of the Traveo. However, this is our latest generation, which is selling into the market, I would say rocking into the market for last few years. And also growing strong. We also have an extended roadmap beyond this family in the Traveo series itself. But if you look at my slide on the left hand side, basically Traveo family is subcategorized into Traveo body, as well as on the right hand side it is categorized into Traveo graphics. So today I'm going to focus on the Traveo graphics portfolio, which is very much relevant to the medical applications, and which I'm going to talk more about in my coming slides. Moving on. So these are the very high level or key features of the Traveo 2 graphics for medical, industrial, and automotive applications. Very important. As I mentioned, this is optimized. This device is optimized for the low power. These are very efficient, very energy efficient processing power. It can go as the deep sleep can go as low as 250 microamps for Traveo 2 graphics devices. In terms of performance, it can deliver up to a DMIPS of 1500. It has dual M7 ARM core. In terms of scalability, the complete portfolio is very scalable, as you might have seen in the previous slide. On the y-axis, we had the performance scalability. On the x-axis, we had the scalability in terms of the memory sizes or the package footprint. The devices starts from 64 pin, goes up to 320 balls. On the safety, it has very high level of safety, meets its safety standard of ISO 262 ASIL-B. Graphics, it has a 2.5D graphics engine built in this microcontroller, which gives the user a feel of 3D. The 3D videos. Audio, it also has an audio it also has a built-in audio. In terms of security, which is one of the very crucial or one of the important aspects which all medical OEMs are looking at, because these days security is becoming more and more important. All these medical devices are supposed to be connected, and hence security plays a very important role. Patient security, patient security. So hence this has a dedicated HSM module, which is M0 plus core. This supports Evita full, and this is also comply with ISO 21434. In terms of connectivity, it has different connectivity options like lint interface, CXI, serial memory interface, which you can configure into octa, dual, quad, SPIs, CAN-FD, and as well as 1 gigabit Ethernet. Updatability, it has a true photo capability with the read while write feature and the combination of HSM. It attributes true photo capability. It also has an interface for eMMC, and as I mentioned, it also has quad SPI, high speed SPI. Moving on, this slides talk about this one. That there are different devices available in the Traveo cluster family, which are mapped into the different medical applications, depending upon the size of the display, depending upon the technology of the display. For the LCD displays, we have devices like CYT 3DL, which suits the best fit. And these kind of displays we see in the blood pressure measurement systems in the hospitals. We also see the displays in the dental implant system, which has a little bit more graphics, advanced graphics, and they are on TFT, which requires a resolution of 720p. There, our device like CYT4DN, which fits in the best. It has two 4 meg VRAM, dedicated VRAM integrated into the device. And then we have the patient monitoring system, which uses full-featured graphics user interface, where you get the high definition experience of 1080p. And with all these devices, so most of these devices are good enough or suitable for addressing 80% or 90% of the medical needs. Of course, there's a lot of displays which requires a lot of graphics requirements. But I would say most of the applications in the medicals can be addressed using these MCUs. Moving on to the next slide. So this is about the graphics subsystem. This graphics subsystem, we have very high resolution graphics engine with an internal VRAM, depending upon the device. Some devices has 2 meg, some devices have 4 meg VRAM. It has a very feature-rich graphic engine. It supports a very high resolution. It has a smart rendering technology which can where we can have a feel of 3D with the 2.5D engine. A very high resolution of 720p with internal VRAM. With sophisticated display controller, the resolution we can achieve is around 2880 cross 1080. As I mentioned, the safety feature, it supports very high level of safety of ISO 26262 compliance. On the video capture, basically this is about the input. If you are not doing the rendering, then you can achieve a resolution of 2880 cross 1080 through MIPI CSI2. It supports JPEG decoder, and it also has flexible memory interface, as I explained before. It is also backward compatible to the previous generation of Traveo devices, and the graphics subsystem has graphics engine, video capture, as well as safety features built in this device. So with this, I would like to hand over my presentation to Jakub. Jakub is gonna talk about the live tracker demo, and that's the most important part of our webinar today. So Jakub, over to you.
Thank you, Ankit. So hello and welcome. Today I will share with you our story of putting together Qt for MCUs and Infineon Traveo boards, which we decided to use for our medical device demo. And let me tell you a bit about myself. So I'm Jakub. I'm principal software engineer at Spyrosoft, and I have some personal attachment to the Qt for MCUs framework because I'm the former member of the Qt for MCUs development team. I've seen the product grow from the prototype to the production-ready solution. It was quite a few years of work, and I'm glad to see that it grows to many platforms, to many solutions, and with that I'm very happy to share with you another story that we had while working with this framework. At Spyrosoft, we support many industries, many technologies, and one of those is HMI development, and in many cases we use Qt ecosystem for that. And as we also work with medical industry, be it patient monitoring devices, life support, or even surgery assistance, we gathered some experience on what the industry expects or how the development workflow works. And we decided that we would like to verify how, from our perspective, it could work with Infineon and Qt for MCUs. And as we have more than 1,600 employees all over the world, we were able to gather the experience for those many projects and apply it to this demo. So yeah, let's start with the usual development workflow. And for us and most of the projects in simplified form, of course, it's starting with the design phase and then moving to development, quality assurance, and finalizing with certification. In terms of working with Qt for MCUs, we start with Qt Design Studio that provides great solution for our designers to quickly prototype their vision, and then move it quickly to actual development with Qt for MCUs to verify those on device and provide the quick feedback loop, so we can quickly iterate over the design, the platform or technical limitations, get back to the drawing board with them, and the prototype can achieve the good shape in very short time, basically because we use the same toolchain that we would use for other platforms. For this demo, we focused on the parts with the Qt design developer workflow and integrating that with Infineon boards. We started with the blank canvas. We asked our designers to create the new patient monitoring device, and they had we'll let them know that they can do anything they can imagine, how the perfect device from their perspective would look like. And we started with this design. Of course, this is the vision that I created, and the device is meant to monitor basically patients' vital signs. The device is the one that you will see in a hospital whenever you are attended. Every patient, the first thing that they do is connect it to the device to monitor the basic parameters of the patient, making sure that he's well, and then decide on the next steps. This device is meant to monitor heart rate, which you can see at the very top with the green digits, respiration in the lower right corner, body temperature, blood pressure, and blood oxygen saturation. So essential parameters that are required to monitor the patient. With that, let me tell you why we even started with Qt for MCUs here. The Qt for MCUs work very well with embedded devices because it provides, as I mentioned, the same designer-developer workflow using the Qt Design Studio and Qt Creator that you know from all other platforms that Qt ecosystem works on. So even if you don't have experience with working with embedded devices, your team is more used to, for example, working in Linux environment with more powerful devices, you can use their experience, the toolchain that they will know very well, to still work on low-powered or basically any embedded platform that is currently supported. With those tools, you have the quick prototyping environment. So you don't need to deploy every time to the target device. You can work quickly with the desktop environment because the same code that will be compiled for your target platform can be also compiled for desktop and quickly verify that it works properly. Maybe sit with the designers and see how it looks like and if it meets their expectations. With that, also Qt for MCUs is very well prepared for being adopted to many different hardware solutions. And by that, I mean, out of the box, it provides already multiple target parts, mostly development kits out of the box that are readily available. There are also many more platforms available on request. And also, you can by yourself adopt it to the target platform that you'll be working on, starting from the development kit, which is then in most cases used to design the very custom-made solution, the hardware solution. This always can be adopted with Qt for MCUs. For this particular projects and working with Infineon Traveo boards, Qt for MCUs provides many more advantages, starting with the on-the-fly rendering, which greatly reduces the memory footprint required for your application, because you don't need to reserve the memory for providing the double buffering. With OTF, everything happens on the fly, and with the performance that the board provides, there's basically no impact on the performance of your application. We even experimented with some crazy ideas, and one of those was VRAM, using VRAM for dynamic allocations, where if you need even more memory that is available, you can quickly adopt Qt for MCUs for things that are not mostly available out of the box. Of course, when working with Traveo, we utilize the hardware accelerated APIs for drawing vector graphics. This is basically game changer because you can provide high resolution user interface without sacrificing the memory required for bitmaps that would normally be used in such cases. Another great feature of Qt for MCUs on Traveo boards is using customizable font rendering engines, so you can decide what do you favor when rendering text. Either you want extremely quick by using bitmap fonts that are mostly based on alpha maps, or you can use the vector-based rendering for your text, which then allows you to maybe sacrifice a little performance, because in Traveo boards the vector rendering is of course hardware accelerated, but the resolution will be better. The last here that I want to mention is using layers for different rendering modes. So Qt for MCUs out of the box supports for hardware layers, and in this case you can decide which parts of your application should use which rendering mode. So if you don't want to use OTF for your whole application, for whatever reason would it be, you can decide to use specific layers for each part of your app, and by that make best use of available resources on your hardware platform. Here's the actual Traveo board that we used for this demo application. This is the T2G cluster 4M Light Kit. So we our demo targeted at this particular board, but with Qt for MCUs you can move it to any other platform that might be supported or will be supported in the future. So let me share you a quick video on how it looks like actually when running on the board. So here it is. Another great thing when working with Traveo boards, and especially useful for developers, you don't need external display to actually see what would be rendered. For this, to capture this video, we use the USB streaming that is available on the Traveo development kit. So this video was directly recorded from there, so that's why the resolution is so high, because this is what you would see in the actual device. So you can see the usual graphs for monitoring history of different parameters. In this case, actually, those values are simulated, but there's nothing stopping us from actually connecting external sensors and making the full featured product based on this demo application. Yeah, so if I can ask to get back to the presentation. Thank you so much. So yeah, with that, what we plan next? What are the next steps for our medical demo? One of probably game changers in terms of embedded world and that is provided by Qt for MCUs is you can use the same QML files that I used to design the user interface for any other platform that Qt supports. And our idea is that the hospitals of the future will have all devices connected. And in this case, we would like to provide the mobile application that will be connected to the patient monitoring device. And with Qt for MCUs, you can reuse the actual QML files that we used for the Traveo board. So the development time is greatly reduced. You can reuse the same business logic that you would use for the embedded platform for mobile device. So the time to develop the connected devices is very short. Of course, as in medical world, we need to provide functional safety, and the solution is ready for Qt for MCUs. In this case, you could use Qt Safe Monitor that provides the detection of any malfunction, and if needed, shutting down or providing the information that something happened that wasn't expected. In this case, when integrating with Traveo boards, the output verification is based on CRC. So the offline calculated values are compared to the graphics output that happens already on the device, and by that you can ensure the integrity of the whole user interface. Of course, you wouldn't use that for every part of the application because it wouldn't be feasible from the performance standpoint, but you can use that for selected parts of the application. In this case, I highlighted simple sample areas that we would consider for Qt Safe monitoring. The last part for the development workflow for the medical devices would be here extensive use of automated tests. And again, when working with Qt for MCUs, you can take advantage of the full ecosystem that Qt provides, and for the embedded platform and Qt for MCUs, it's no different from any other. You can adopt Squish to create automated tests, and even better, because with Qt for MCUs, it is possible to adopt it to custom hardware. So your automated test can be executed on target device. So there's no need to use simulated environment. You can during the development cycle, you can always automate the testing on the target platform. Another advantage of Qt for MCUs is that the QML code is translated into C++. So we can use any other static analysis tools that you would use for any C++ based project that targets embedded platforms. So there's no need to look for some custom solutions and looking for also for certification. Any part of your existing development toolchain that would target C++ can be adopted to be used with Qt for MCUs. And of course, when it comes to software certification, Qt for MCUs also supports that. So you can see that the whole development workflow for medical area can be maintained by using Qt ecosystem. With that, I conclude my presentation. Thank you for your attention, and Tony, back to you.
Thank you, Ankit. Thank you, Jakub, for presentation. Now is the time to ask questions. If you have any questions to any of the speakers on the topic. You can see there's the first one already. Believe maybe Ankit, you are the best to answer. Which kind of MCUs would one consider for medical use cases? So I guess that this is about the features.
Yeah. So I can take this question. So as I mentioned, right, for the medical use cases or medical applications, really critical for the customers or the OEMs is low power, safety, because they need to ensure that it is working well, and the security, since the devices are now medical devices are supposed to be connected these days. The privacy of the patient information is really, really critical. So these three attributes, and of course the longevity of the devices, availability of these devices for a long time, is also another criteria. And with this, I would say Traveo 2 graphics is the right candidate, which has all the attributes which I mentioned.
Okay, thank you. So there is another question about text rendering. So I'm not sure who is the right person to answer, but I will ask, how is the text rendered with Qt for MCUs, and what are the performance implications? Maybe Jakub, you can.
So as I mentioned, basically right now you have possibilities to use two modes. One would be based on alpha maps, so you would need to render it. So Qt for MCUs would then prepare automatically alpha maps based on your QML code, and then it provides great performance, but can affect your memory footprint, because for each size, style of your text, you will have separate alpha maps. If you want to avoid that, then there's the other mode based on vector fonts. So then, depending on the platform, either if it provides the hardware accelerated APIs for vector rendering, the performance will be very good or might be affected, because then the actual vector rendering would be happening on the CPU. But still, memory footprint would be much lower.
Okay. Thank you for comprehensive answer. Okay, then there is a question about challenges. So what challenges OEMs like Philips/GM, I believe that's, are facing while selecting graphics MCU for standalone patient monitoring system? So what kind of challenges are they facing when selecting MCUs for standalone?
I can take this question, Tony. Okay, so it's not just about Philips or GM, it's about every OEMs who is playing in this medical space. As I mentioned, the few items like low power consumption, safety, security are the key. Of course, they're really important for the OEMs. But another thing, very, very important, is doing more with the less. So they want to have an MCU which can really have a very high, basically very high level of graphics performance. So with the graphics engine that we have in our devices, customers, and we also have done a benchmarking together with our partner Qt, right? You will get to see with a low memory footprint, we are able to achieve more high resolutions. So this is also one of the important aspects that OEMs are looking at.
Okay.
Yeah.
Thank you. So then this next one probably could be either to Ankit or Jakub, but this is the USB streaming native to this device, or are there other open hardware devices that support this capability?
Okay, so I'm sure there are, but for this one we actually focused on the Infineon Traveo, and in this case it provided us a very good way of working and quickly prototyping on the target device. But I'm not so sure what are the other devices that support this capability. I'm not sure, Ankit, maybe you can provide this.
No, we don't have USB streaming here, but there are different ways. We have different communications. Customers can connect the Ethernet. Yeah, they can stream it with the Ethernet for the high power. If they need a very basically a high speed connectivity, of course, Ethernet is an option with our devices.
Okay, so then there is a question about integrating sensors. So how to integrate external sensors with Qt for MCU applications?
So I guess this is also for me. In our case, the demo application uses only single core, and the Traveo board provides 2 cores. So our idea is to utilize the second core for actual business logic and communication with external sensors. Qt for MCUs underneath uses C++ API, so it's quite convenient to provide this communication and to not affect the rendering performance. So basically the second core would be used to connect those sensors, and with either communication solution that is available on Traveo, it's basically quite straightforward to do that.
Okay. Then there was a talk about testing, and there is a question about, are there any solutions that allow testing of these medical graphical user interfaces on real production hardware?
I think it's for Jakub. Yep.
So as I mentioned in my presentation, basically we would use Squish for that. Of course, depending on the target hardware that you used, some adaptation would be required to make sure that Squish can communicate and execute those automated tests on your hardware.
Okay. Are there any other questions? I'm just checking this chat box. So then I thank you everybody joining today, attending this webinar, and thank you Jakub, Ankit for presentations, and I wish you very good continuation of the day.
Thank you, Tony, for hosting us.
Thanks.
Thank you so much.
Bye-bye.
Bye.
Bye.